Hey students, once again in this video we're going to talk about solving equations. Just like our previous video, we're going to learn how to solve two-step equations eventually, and this is going to help us get there. Same with our I can statement. It's going to help us get to the point where we can solve two-step real-world mathematical problems and equations using rational numbers. We've already talked about what an equation is. In our last video, we talked about the balance, and that helped us develop this rule where whatever you do to one side of the equation, you have to do the exact same thing to the other side of the equation. Okay, so rule, whatever you do to one side, you must do to the other. Our goal, what we're trying to do, when we say solve an equation, it means get the variable by itself. Find out what that variable equals. In order to do that, we have to get it by itself. We have to isolate it. So our goal is to get the variable by itself. We're going to focus on using multiplication and division in this video. So again, to isolate the variable, we're going to use inverse operations, which are just operations that undo each other. And these are opposite operations. Inverse, another word for opposite. So whatever operation you see in the equation, we're going to do the opposite. So the equations are going to look a little different. When we see division, we're going to multiply each side by some number to eliminate it, to do the opposite of it. When we see division taking place, we would multiply. So we do the inverse, we do the opposite every time. And then just like in our last video, you can always check your solution by substituting it into the original equation and checking to make sure that it's equal. So let's jump in. In number one, 8y equals 72. These are right next to each other. I'm sure you guys already know this, but when there's a number and a variable right next to each other, that means they are being multiplied. So that really says 8 times y equals 72. And like we said over here, whatever we see taking place, we do the opposite. So if we see multiplication, the opposite of multiplication is division. In this case, we're multiplying by 8, so we're going to divide by 8. Now, you might want to use this symbol and say divide by 8. That actually doesn't work very well in algebra. Instead, what works instead of that division symbol is a fraction bar. So I want you to get used to using a fraction bar to show division. And when we're dividing by 8, we put an 8 under it. So we divided by 8 on this side. We do the exact same thing on this side because that's what our rule says, divide by 8. Now, 8 divided by 8, or 8y divided by 8. The 8's cancel. 8 divided by 8 is just 1. So this says 1y, or just y, equals, and on the other side, 72 divided by 8 is 9. Our variable is isolated, so our solution is y equals 9. All that's left is for us to check it, so let's copy the original. And instead of 8 times y, we know that y equals 9, or at least we think y equals 9, so we're going to change it. I'm going to put it in parentheses so that it doesn't look like an 89. So this means 8 times 9, because that's what our solution was. 8 times 9 is 72. Drop down the other 72. We have the same number on both sides. That verifies that y equals 9. Now in this one, we have a fraction. So this fraction right here, this means division. So m divided by 4 is what that says. M divided by 4 is our equation, equals negative 13. So if we see division, the opposite of that would be multiplication. Opposite of dividing by 4 is multiplying by 4. So I'm going to go off to the side here. I'm going to multiply by 4. And whatever I do to one side, I have to do to the other. This dot means multiplication. And I'm going to show you what happens in this first one. You don't have to do this every single time, but if we were actually multiplying this, we would want to turn this into a fraction. 4 times m would really give us 4m in the numerator. The denominator would be 1 times 4, which is 4. And then 4m divided by 4. The 4's just cancel. 4 divided by 4 is 1. So these cancel. All that's left is really m. Okay? You don't have to show this step every single time. You could just show right here. The 4's cancel and you're left with m over 1, which is just m. Now let's multiply on the other side. Negative 13 times 4, that's something that if you don't know, you could go off to the side and multiply. That'd be 12, carry the 1, that would be 5. It's a negative times a positive, so this would be negative 52. M is by itself, So our solution is m equals negative 52. Now let's check it. So m over 4 equals negative 13. For m, I'm plugging in negative 52. So I'm going to rewrite this as negative 52 over 4 equals negative 13. Negative 52 divided by 4 is what this fraction means. So I'm thinking 4 times what gives me 52? Well, it was 13, right? And this is a negative divided by a positive. So I know my answer is going to be negative 13. Drop down the other negative 13. Shows that they're equal. That verifies that m equals negative 52. Number 3, draw my line. This time the variable's on the right. And let's ask ourselves, what operation is taking place here? They're right next to each other. That means multiplication. So the opposite of that is division. X is being multiplied by negative 5. So the opposite would be to divide by negative 5. Make sure you divide by negative 5. Do the same thing on the other side. The negative 5s are going to cancel. All that's left is X. 45 divided by negative 5. Positive divided by negative is negative. 45 divided by 5 is 9. If you want, you can rewrite this with the variable on the left. X equals negative 9. All that's left is to check it. Copy the original equation down. Where I see X, I'm going to put negative 9. So 45 equals negative 5 times negative 9. Again, the parentheses are just to separate it so they don't run together. Drop this 45 down. Negative 5 times negative 9. Negative times negative is positive. 5 times 9 is 45. 45 on both sides. So that verifies this solution is correct. One more. Variables on the right side of the equal sign. Let's draw our line down so we can separate our work. This fraction means division again. So m is being divided by 16. The opposite of that, or the inverse of that, would be to multiply by 16. So on this side, I'm also multiplying negative 2 by 16. Like I showed you in the first one, the 16s are going to cancel. That's going to leave just m. Over here, 16 times negative 2. Positive times negative is negative. 16 times 2 is 32. If you want, you can put the m on the left side. M equals negative 32. Let's check it. Copy the original. Instead of m over 16, we're going to change that and use our solution in place of m, negative 32 over 16. Drop the negative 2 down. We have a negative divided by a positive, so that's going to be negative. 32 divided by 16 is 2, so negative 2 equals negative 2. It shows equality, so our solution of m equals negative 32 is correct. In closing, we are another step closer to solving two-step real-world equations and problems using rational numbers. We learned how to use other types of inverse operations in this lesson. So we learned how to use multiplication and division as our inverse operations to isolate the variable. And again, we looked at checking the solution. So we are one step closer to solving these two-step equations. Hope this helps you even more with one-step equations. Have a great day.